Hi, my name is Joost Batenburg and I'm a researcher at the Vision Lab of the University of Antwerp in Belgium. Today I will tell you something about our desktop supercomputer project called FASTRA. But before telling you about the amazing computing capabilities of our system, I will need to explain what we're using it for, which is tomography. Well, tomography is a technique used by doctors to create three-dimensional images of the internal organs of their patients. Let's go to an X-ray CT scanner to find out how it works. Suppose our patient here, let's call him Bob, has a medical problem and needs to be examined by a doctor. I hand him over to Dr. Postnov now, and the doctor puts him in a CT scanner. In fact, here you see a small version of a real medical CT scanner called a micro CT. It is then possible to view on the screen X-ray images of Bob. The scanner now records a series of X-ray photos from a range of angles going around the patient. This series of photos can then be combined into a three-dimensional image of the patient by a mathematical procedure known as tomographic reconstruction. This 3D image can then be visualized in several ways, for example taking slices of cross-sections and 3D volume rendering. Well, these 3D volumes can get pretty big. They can easily consist of billions of volume elements. Traditional methods for computing a tomographic reconstruction are very powerful and also quite fast, but they have three major disadvantages. First of all, they require a large number of X-ray photos, so a long scanning time. Second, the photos must be taken over a wide range of angles going all around the patient. And third, these methods cannot deal well with experimental noise. You will see now three images reconstructed, first with few X-ray photos, now with a small angular range, and from very noisy data. In many practical applications of tomography, not just in medicine but also in industry and science, we have certain prior knowledge of the object that we're scanning. For example, our patient Bob here, we know that he is made of plastic. If this were a real person, he would be made of bone and water mainly. At the ASTRA research group in Antwerp, we are developing new methods that take this prior knowledge into account. By exploiting this knowledge in the reconstruction method, we are capable of dealing with few projection images, a small angular range, and even noisy data. You will now see three reconstructed cross-sections of Bob, taking the prior knowledge of the plastic density into account. First with few projections, then with a small angular range, and with noisy data. Our tomography methods that use prior knowledge are very powerful, but they also have a major disadvantage, which is the reconstruction time. Even on our small cluster here, consisting of 4 quad-core PCs, a reconstruction of a large three-dimensional volume can easily take days, compared to maybe 10 minutes for traditional methods. We considered the option of going to our local supercomputer here in Antwerp, which is a 512 node cluster. But this has three drawbacks. First of all, it is expensive. Second, it is not always available to us. And third, other research groups that don't have a supercomputer would not be able to use our techniques. So we really needed something a lot better than that. Surprisingly, the key to doing our computations fast was not in going for lots of PCs, but in fact to use 3D gaming hardware. Here you see a 3D graphics card which is normally used to play games. Such a card contains a processor called a GPU, and this processor consists of up to 128 smaller subprocessors that can all work in parallel. Now fortunately for us, a GPU can not just be used for playing 3D games, but also for doing more general computations, such as tomography. In fact, a single 3D card can already be up to 40 times as powerful as a normal PC for tomography. Now we decided that that is still not enough, so we built an extremely powerful super PC which contains 8 GPUs. It's called the FASTRA. Hi.
Oh, hi.
As you can see, the FASTRA is made completely from consumer hardware. It has 4 graphics cards, each containing 2 GPUs. So this is 8 GPUs working in total, and each GPU has 128 processors, making for a total of more than 1,000 small processors working together. It is powered by a 1500 watt power supply, and as far as we know, this is the first normal PC in the world that actually has 8 GPUs. Best of all, because it's made from consumer hardware, it costs less than €4,000, making it affordable for any scientist.
I just started the reconstruction, running on all 8 GPUs. Before FASTRA, it took about an hour. As you can see, it's now almost finished. It's like 30 seconds. Just wait for a bit. And there it is.
GPU computing, so doing general computations on graphics hardware, is a very powerful technique. For tomography, we believe that with FASTRA we've created the most powerful single PC in the world for doing our computations. Supercomputer performance, the same like a 512 node cluster within a single PC for less than €4,000. It doesn't get much better than that. Now we're currently using the FASTRA for all kinds of tomography projects in medicine, industry and science. If you want to learn more about our research at the ASTRA group, please visit our website fastra.ua.ac.be.